Okay, day 2, and if you notice, this one might be a little bit different. Well, maybe not. I know when we get later on in the unit, the days are off. This one, actually, we took it out last year. So I didn't make a video last year for this one, so I had to move all the dates, or all the days back. So this one's day 2. Their next video, day 3, will say day 2 at the top. Yours will say day 2, simplifying rational expressions. Just ignore that. Okay, so we took this out last year. It was originally supposed to be in there. So our learning target is I can use and interpret combined variation. So yesterday you did some direct variation, inverse variation. Now we're going to combine it. So yesterday it was always one variable varies with respect to another. Today we're going to talk about when one variable, one quantity varies with respect to 2 or more quantities. The big thing here is K is always on top. If it says directly, then it goes on top. If it says inversely, it goes on bottom. Okay, so like whenever it says y varies directly with the square of x, y varies directly, we're going to put a k on top and then the square of x on top, so it would be k squared. When it says varies inversely with the cube of x, so that goes on bottom, k stays on top. K is always on top. Okay, when it says varies jointly, jointly is just another word for saying directly but with more than one. Okay, so it's the same thing as directly, but it's just more than one quantity. So z varies jointly. It's like saying directly with the product of x and y, and then there's a k on top with it. So it would be z equals kxy. Z varies jointly with x and y, so they go on top. So k goes on top, k is always on top, x and y, and then inversely with w, that means w goes on bottom. So inversely, put it on bottom. So inversely on bottom. And then, so that's just k is always on top. Directly or jointly means goes on top. Inversely means goes on bottom. Think of it that way. So write a combined variation that models a relationship. So z varies directly with x. So z varies directly with x. And there's always a k on top. And inversely with y. So y goes on bottom. Now, when x equals 6, y equals 2, z equals 15. That information is so you can find your k. So z equals 15, x equals 6, and then y equals 2. And now solve. Well, first off, 6 divided by 2 would be 3, so this is k times 3. If I divide that 3 over, k equals 5. So my equation, my model would be z equals, and I'm just going to rewrite this, but plug the k in, 5 times x over y. Now, they want us to find z when x is 4 and y is 9. So plug those in to the for x and y, plug in 4 and 9. So this would be 20 divided by 9. And you could just leave like that, 20 divided by 9. So look at the bottom here. We're giving you the equation, and you have to write it using words. So basically I give you this, I'm going the opposite direction, I'll have you write words. So if it's this right here, so m, and if n is on top, then that's direct variation. If v squared is on bottom, that's inverse. So the mass varies directly with, on this one it'd be twice n, with twice, and this is the kinetic energy, because n is kinetic energy, so twice the kinetic energy and inversely with the velocity squared. You could say the square of velocity, or the velocity squared. This guy here. Now, I've got two things. They're both on top. So I can say, instead of saying directly, I'll say jointly, because there's two of them on top being multiplied together. So the area of a trapezoid, I'll just put trap, varies jointly, and the k is a half, so I'm just going to say jointly with 1/2 the height and the sum of the bases. Okay. Bottom one here, now there's the only variable on the right side is r, because 4/3 and pi are constants. So because they're constants, they're just the k. So like this right here is k, so I got r cubed. So the volume should be the volume of a sphere, a sphere, got the word is going to varies jointly with 4/3 pi of the radius cubed. Okay, so again, there's only one variable, so I just say, I'm sorry, not jointly, directly. I think I made a point to say that, and then I put jointly. It's only directly because it's only one variable. It'd be jointly if there was more than one variable over there. So, yeah, even in my notes that I'm reading here, because I wrote this through, I have directly, but I wrote jointly for some reason. Okay, backside. So now let's get to using some of these. So it says that z varies jointly with x and y. So all that means z equals kxy. Okay, jointly just means directly. When x is 7, y is 2, z is 28. They're giving you the information so that you can find k. This is 14, so I'm going to divide both sides by 14. So k equals 2, which just means that my equation, my relationship then, is z equals 2. I'm going to put a 2 in for k, x, y. So that's my answer. Once I solve for k, that's my actual answer. Let's see here. Then it says find z when x is 6 and y is 4. So z equals 2 times x is 6, y is 4. So this would be 24 times 2 is 48. So that'd be your second answer. Okay, so be careful how many answers. Just solving for a k is not it. That's not your answer. You have to actually find the model. The relationship is z equals 2 times x times y. Z varies directly with x and inversely with the cube of y. Okay, whoops. So directly, x goes on top. Inversely with y cubed, it goes on bottom. K always goes on top. Now, take the information they give you to solve for k. So when z is 3, x is 8, and y is 2. So this is 2 cubed. So this would be 8 over 8. Now that's going to reduce, so k must be 3. So z equals 3 times x divided by y cubed. That's my relationship. Now up here, find what z is when x is 6. So z equals 3 times x is 6, and when y is 4, so y, or 4 to the third goes on bottom. This would be 18 divided by 64, which reduces to 9/32, and that's about as far as you have to go with that. Okay, now reviewing this, So is it direct, is it inverse, or is it neither? This is from yesterday. So if you remember, to be direct, the quotients are all the same. Take y divided by x. If it's inverse, the products are the same. So when I look at these, are the quotients all the same? So is 10 divided by 2 the same as 5 divided by 4? Is that the same as 4 divided by 5? Well, that's not true. So it's not direct. Not direct. Now check the products. Is 10 times 2, does that equal 5 times 4, which equals 4 times 5? 20, 20, 20. So that is true. So it is inverse. Inverse. And then write the equation that models it. So if you remember from yesterday, y equals k over x is for your inverse. So if I bring the x over, that's just x times y equals k. So if I want to find k, I just multiply them together. Well, I did that several times. That's 20. So k equals 20. So y equals 20 divided by x. Just plug it in for k, and there's my relationship. Okay, check all these. Is 6 divided by 1, is that the same as 12 divided by 2? Is that the same as 30 divided by 5? They're all 6, so that is direct. So that is direct. If you remember from yesterday, that constant variation is, because it is the quotient, 6, so k equals 6. So this one's going to be y equals 6 times x. So let's plug that in for k, because y equals kx is the standard one. Now for this guy, are the quotients the same? Is 2 divided by 1 the same as 8 divided by 3? Nope. How about is 2 times 1 the same as 8 times 3? Nope. So it's not direct, it's not inverse, it's neither. So that's just a quick review from yesterday.